Hello, my name is Rishti Shastri and I will be presenting a matrix suite for object-oriented design by Dr. Shyam Chidambar and Dr. Chris Kammerer. Dr. Shyam Chidambar completed his PhD from Massachusetts Institute of Technology and Dr. Chris Kammerer completed his PhD from Carnegie Mellon University. His H index is 46. This paper was published in June 1994 and the paper has been cited for 7,355 times. Earlier there was criticism on the SOFIA matrix, such as it does not have any theoretical base and lack appropriate properties. Other authors also commented that there is no theoretical rigor and does not possess mathematical properties. Another reason behind the criticism was that the SOFIA matrix was not supporting the key concepts of object-oriented design and also failed to display the normal predictable behavior. After these criticisms, it was needed to construct a SOFIA matrix with strong mathematical and theoretical rigor and should also be able to measure unique aspects of object-oriented approach. So the main agenda of the paper is to first, propose matrix with theoretical concepts and measurement. Second, validation of proposed metrics against validity criteria. Third, illustrating how these metrics can be used. There were some steps in object-oriented design process. First is identification of classes. Here we define the problem and also identify the part of our problem domain. Second, identifying the semantics of classes and objects. In this step, the semantics of classes and objects are created. Third, identifying relationship between the classes and objects. Here the interaction between the classes and objects are identified. Fourth, implementation of classes and objects. Here in this step, detailed internal views are created. And class design is the highest priority in object-oriented design, and it must occur before system design and program design. According to Roberts, object-oriented design can be conceptualized as relational system, which consist of binary operations, empirical relations, and object elements. Here in first equation, A is a set of objects, R represents empirical relations, and O represent the binary relations. Measurement of complexity is one of the useful way to understand the empirical relation. An empirical relational system needs to be transformed to formal relational system to be able to measure something about object design. And in this second equation, the C is the set of elements, S represents the formal relations, and B represents the binary operation. There are some concepts which are defined in the paper. First, coupling. It is the degree to which one class knows about another class. Second, cohesion. The degree of similarity of two things are defined to be intersection of set of properties of two things. Third, complexity of an object is defined to be the numerosity of its composition. Fourth, scope of properties means a class is a set of objects that have common properties. Fifth, method is measure of communication. In object-oriented approach, the object communicate through message passing. Sixth, combination of object classes. Class design is an iterative process involving subclassing, factoring, and composition that unites existing classes into one. Now to evaluate proposed metrics, it is desirable to have formal set of criteria. Vuker proposed 9 properties. The first property means that not every class can have same value for metric. Second property means there are only finite number of classes with same complexity. Third property states that there are multiple classes of same complexity. Fourth property states that design details are important for determining the metrics of class. According to fifth property, the metric for combination of two classes can never be less than the metric for either of the component class. Sixth property states that if a new class is appended to classes having same class complexity, then class complexities of two new combined classes are different. Seventh property states that the metric value changes due to permutation of classes. Eighth property states that renaming the classes or object will not affect the complexity of class. And finally, the ninth property states that when two classes are combined, then interaction between the classes can increase complexity metric value. There are three assumptions made regarding distribution, instance variables, and methods. First, statistical distribution is followed by number of methods, variables, and coupling, which is not apparent to the observer of the system. So observer cannot predict the variables, methods, and coupling of one class based on the knowledge of another class. Second, two classes can have finite number of identical methods. So the combination of both classes would result in one class's version of identical methods becoming redundant. Third, the inheritance tree is full. That means application does not only consist standalone classes, there is some use of subclassing also. The viewpoints which are used in this paper to construct matrix are gathered from the extensive collaboration with highly experienced software team, and the matrix proposed in the paper were collected from two different organizations, Site A and Site B, where Site A is a software vendor that uses object-oriented design in their development and also has collection of C++ libraries, and Site B is a semiconductor manufacturer which uses Smalltalk programming language for developing manufacturing systems and flexible machine control. Six metrics are proposed by the authors. Weighted method per class WMC measures the complexity of class and predicts how much time and effort is required to develop and maintain the class. The possibility of reuse is limited if the class have large number of methods. Also, large number of methods means greater impact on derived class. When we look at the graph, it is quite clear that distribution at site A and site B are similar, but the only differences are in the language used, the people involved, and the nature of the application. Next metric is depth of inheritance tree. This metric is the maximum length from the node to the root of the tree. The deeper the tree will be, the more methods and variables it is likely to inherit. If the value of depth of inheritance is large, that means many methods might be reused. From the graphs, we can see that both site A and site B have low median values for DIT metric. At both site A and site B, the library appear to be top-heavy, which suggests that designers may not be taking advantage of reuse of methods through inheritance. Designing this class would be simple, but testing could be complicated because of inheritance. The third metric is number of children, which is equal to the number of immediate child classes derived from the base class. If the number of children increases, that means reuse increases. After looking at the data, it is observed that there is similarity in the nature of distribution of metric values at site A and site B. And after considering large sample sizes at both the sites, both DIT and NOC data seem to strongly suggest that reuse through inheritance may not be being fully adopted in class libraries design, at least at these two sites. Coupling between object classes is a metric which counts the number of other classes to which it is coupled. A class is said to be coupled with another class if the methods of one class use the methods or attributes of other class. Here both site A and site B class libraries have skewed distribution of CBO count. At site A, the class with high CBO value was also the class with high NOC value, which suggests that there is a need to re-evaluate that portion of design. Response of a class is the number of methods that can be invoked in response to a message in class. If RFC increases, then the effort required for testing also increases, and the design complexity of class also increases. The data from both the sites suggest that most of the classes tend to invoke small number of methods. Also, there is difference in median and maximum values of both the sites, and the values at site B are higher than site A. Since there are a number of classes that are stand-alone, that means no coupling, no children, and no parents, the RFC values for these tend to be low. Lack of cohesion in methods is a metric which is used to measure the amount of cohesiveness present, and it uses the notion of similarity of methods. The lack of cohesion in methods is the count of number of method whose similarity is 0 minus the count of method pair whose similarity is not 0. The LCOM median values are extremely low at both the sites, which indicates that at least 50% of classes have cohesive methods. By looking at the shape of two distributions, it is clear that Site A application has few outliers class that have low cohesion, whereas Site B application have no outliers. This metric can be used to identify the class that are attempting to achieve different objectives, as they are likely to behave in less predictable way as compared to the classes having low LCOM. So 6 metrics were explained, and by looking at the table we can see that WMC, DIT and NOC related to the identification of class step in object-oriented design. Also, WMC, RFC, and LCOM relate to second step, which is semantics of class. When we look at the analytical results, we can say that all metrics satisfies majority of properties, but property 6 is not met by any metric. But also according to the viewpoint, satisfying property 6 is not an essential feature for object-oriented design. After having data from two different sites, it is observed that designers may tend to keep the inheritance in hierarchies shallow, and managers need to be proactively manage reuse opportunities. And these metrics can be used to allocate testing resources and can act as a tool to meet the challenges. In this paper, a new set of software metrics have been developed, which also reflected the viewpoint of object-oriented software developers. After evaluating the metrics, it is found that they possess a number of desirable properties and also suggested some ways in which object-oriented approach may differ from traditional approach. Using the metrics can also identify the potential flaws, leverage points in design, and also the areas of application which require rigorous testing. Also, these metrics can help to select the appropriate object-oriented design. One of the future work can be to analyze the degree to which these metrics are correlated with managerial indicators. Also, following the commercial application from conception to deployment and gathering the metrics at various intermediate stage can be another study in future.